Chapter 3 Calculations with Chemical Formulas and Equations. Topic 1 Molecular Formula Weight, mole, and molar mass. The first part, we will consider about atomic mass unit AMU. We already knew in the previous part, 1 AMU is equal to 1 over 12 of the mass of carbon 12 atom. So it means that you have 1 atom of carbon 12. The mass will be 12 AMU. By doing some experiment, and we know the relative atomic mass of the other atom with carbon 12. So we also know the mass of the other atom. We may have hydrogen 1 or maybe we have oxygen 16 and we know the value already. And we also know that for one element, we may have more than one isotope. For hydrogen, we may have hydrogen 1, hydrogen 2, hydrogen 3, okay? And then we can calculate the average atomic mass of natural isotope in AMU. And usually we just consider about a stable isotope in the nature. And we get the value, and that one is the atomic weight, okay? So atomic weight can be calculated by using this equation. You calculate the sum of the isotopic mass times with the fractional abundance of that isotope, okay? And in this part, we consider about the molecular weight. So molecular weight, we will calculate for the molecules or the molecular substance. We may consider about H2O, okay? That is the sum of the atomic weight of all the atoms in a molecules of the substance, okay? So from here, you know the mass of hydrogen, you know the mass of oxygen, okay? And then you can calculate for molecular weight equal to the mass of hydrogen times with 2 because you have 2 hydrogen atoms in your structure, plus with the mass of oxygen because you have only 1 oxygen in your structure, okay? And the next term we consider about the formula weight. Formula weight, we also calculate the sum of the atomic weight of all atoms in a formula unit of the compound, whether molecular or not. It means that for molecular weight, we consider about the general form. We may have the waters as the reverse one, or we also can consider to calculate for NaCl as well, okay? So we have the general equation here. If we have the compound ANPM, so in our structure, we have N atom of A, and we have M atom of B, okay? And then you can calculate the formula weight by using this equation. Because we have N atom of A, so N times with the mass of A, plus with M times with the mass of B, and then we can get the formula weight, okay? So, you see we have the same equation to calculate for molecular weight and formula weight, but molecular weight only for molecular substance, but formula weight we can calculate in the general form. So from here, if we have NaCl, so we can calculate for the formula weight equal to the mass of Na plus with the mass of Cl, because we have only one Na and one Cl. So from here, we have any substance, we can calculate the formula weight by using this equation, because you already know the mass for our atom already, okay? For element, for each element, we have atomic weight already, okay? And the unit for your calculation here will be AMU, because we use AMU from our atom and we calculate for the substance, so the unit also AMU, okay? And the next part, we consider about the mole concept. So how to calculate for a chemical reaction? If you come to the supermarket, you want to buy something, and for something we use the weight to calculate, something we use the volume to calculate, or something we use the particular number to calculate, and you make the payment. And when you make the payment and we change it become the money. Or if you have something to sell and then you buy some other thing. So it means that we also use the money for our exchange. Okay. And similar, for the chemical reaction, in our chemical reaction, we have the arrangement of the structure. Okay. And in our reaction, we may consider about atom for your reaction. We may have the molecules for our reaction, or we may have the ions as well. Okay. So when we make the calculation for the chemical reaction, we will consider about the mole concept. It's similar with the money. So everything just change to the mole and we can make the calculation. Okay. So we consider about a chemical reaction. We have iron react with oxygen and we can get Fe3O4. Okay. You already know how to write the chemical equation from our description already. And from here, we see that on the right, we have 3 iron. So we need to make balance for iron on the left, 3 iron here. And oxygen, we have 4 oxygen. So on the left, we make the balance 2 oxygen molecules. Okay. Because oxygen is the gas, so we have O2 here. Okay. And we get the balancing chemical equation. Okay. And in this equation, you can see 3 iron. It means that we have 3 iron atoms react with 2 oxygen. 2 oxygen. Oxygen, we call that one is the molecules because we have 2 atoms with the chemical bonding with between 2 atoms. Okay. So we have 3 iron atoms react with 2 oxygen molecules. And then we get only 1 Fe3O4. So in this structure. And we call that one is 1 iron 2 3 oxide formula unit. We have only one. Okay. And you see we cannot use the mass for your calculation because usually in chemical reaction we consider about the mass of the substance or maybe sometimes we know the volume and the concentration for your calculation. Okay. But we cannot use this one or this one directly in the calculation in the chemical equation because if we know the mass of the first substance, we don't know how many grams of the second substance. Because in our chemical reaction here, we see we have 3 atoms react with 2 molecules. It means that the number of atoms or molecules in our chemical reaction. Okay, not the mass. So if you know the mass for the first substance, we don't know how much for the mass of the second substance by calculating directly. Okay, and in 3 gram, example, we have 3 gram of iron or maybe any mass of iron. We also don't know how many atoms. For chemical reaction, we care about the number of atoms in the reaction. Okay, but if we consider the mass, we don't know how many atoms. So we should change become the mole for your calculation. That's the reason why we need to know the mole for your calculation in chemical reaction. We cannot use the mass because for chemical reaction, we care about the number of our atom or molecules or the formula unit. Okay. And we define the mole. We use the symbol N for mole or notation N. Okay. And from here, 1 mole, it means that the quantity of a given amount of substance that contains as many molecules or formula units as the number of atoms in exactly 12 grams of carbon 12. Okay, 12 grams of carbon 12. So we also use carbon 12 as the standard. So if we have carbon 12 atom and we have 12 grams of carbon 12 and how many atoms of carbon 12 inside, and we call that amount is 1 mole. So it means that if we consider 1 mole for any substance, the same number with the number of atoms in 12 grams of carbon 12. Okay, and the number of the atom in exactly 12 grams of carbon 12 is Na equal to 6.02 times with 10 power 23. Okay, and this one we use 3 significant figure. Actually, this one is the long number, but we use 3 significant figure in our course here. Okay, or this value you also can check from your calculator, and this number we call that one is the Avogadro number, the name of scientist. Okay, so from here we can see 1 mole of something consists of 6.02 times with 10 power 23 unit of that substance. Okay, so we consider 1 mole of any substance. We have the different mass, okay, different amount, okay, but the number of the unit inside will be the same. We may consider about this molecule. So 1 mole is mean that we have Na molecules, or we may consider about this any substance. So 1 mole we have this Na number of the formula unit. Okay, or for this one we also have the same. This one is molecular substance. So we have 1 mole, we have Na molecules, okay, or maybe for this substance as well. Okay, so we know that 1 mole of any substance we have Na equal to 6.02 times with 10 power 23 formula unit. Maybe atom, maybe the molecules, or maybe the formula unit if we consider about substance. Okay, so if you know the mole number, any mole number, unmole, and then you can calculate for the real number of the unit in our substance. So we can use this equation to calculate the number of unit equal to the mole number times with Na. So if you have 1 mole, we have Na unit. If you have 0.5 mole, it means that you have a half of this number. If you have 2 mole, you have 2 times with this number. So if you consider about the mole number, and then you can know the number of the unit in your substance. Okay, because you know about this one, you can use in our chemical equation for your calculation. Okay, and the next one, we consider about mole for molecules and mole for any substance. And we already know 1 mole. It means that we have Na equal to 6.02 times with 10 power 23 unit. Okay, so when we consider about molecules, so it means that this value, we call this one is molecules. Okay, so 1 mole of ethanol, because ethanol is the molecules, and we have 6.02 times with 10 power 23 ethanol molecule. Okay, but if you consider about ionic substance, so we have the unit, not the molecules. Okay, so 1 mole of sodium carbonate, Na2CO3, this is ionic substance, and we have 6.02 times with 10 power 23 Na2CO3 unit. Okay, so we just use a different name. This one we call this one is the unit, and this one we call this one is the molecule. Okay, and in our ionic substance we have ion inside, and in Na2CO3, so we have 2 Na plus and CO3 2 minus. We have 2 cation, 2 ion here and 1 ion here. Okay, so we have 2 Na plus and 1 CO3 2 minus ions. Okay, and from here we can see because 1 unit we have 2 Na plus, so the number of Na plus will be 2 times with this value, because you can see 1 mole, right? 1 mole we have this number for the unit, but in 1 unit we have 2 Na, so the number of Na plus in 1 mole will be 2 times with 6.02 times with 10 power 23 Na plus ions. Okay, and similar, 1 mole we have only 1 unit here and have only 1 CO3 2 minus. So the number of CO3 2 minus ion will be equal to Na unit. Okay, Na ion only. Okay, so when we consider about this substance, we can see we have the difference for the positive charge and the negative charge in our structure. So from here we can see that we have this is anion and this one is the cation. So when we dissolve in water or we melt our substance, it can change become cation and anion. So we have 2 Na plus and 1 CO3 2 minus. Okay, and this one you can see this one is the metal, and this group will be the non-metal. So we have the ionic substance we already mentioned. And in this group, and you can see non-metal, 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 non-metal. So we have the covalent bond between our atom. Okay, and this one will be one group for the ion, anion. We cannot separate it become the single atom. Okay, so we can see two different, right? The first one about molecules, the second one about substance, and the number of the unit in our substance will be the same. 1 mole will have Na. Okay, and in addition, if we consider about ionic substance, we care about the number of ion, cation or anion. But in our molecules, we may consider about the number of the atom. It's okay, but we don't have ion. Okay. In here, if we have the structure here, we have one oxygen inside. So it means that 1 mole of ethanol, we also have the same number of oxygen atom. Okay. If we consider about the carbon, so inside we have 1 and 2 carbon. So it means that 1 mole of ethanol, we have 2 times with an A carbon atom. Or we consider about our hydrogen, we have 1, 2, 3, 4, 5. Okay. And in this structure, actually inside we have another one. So we have 6 carbon, 6 hydrogen. So we have 6 hydrogen, it means that we have 6 times with an A. Okay. So the number of atom. So for molecular substance, we consider about the number of the molecules in general, or the number of each atom inside. But for ionic substance, we consider about the unit, and we consider about the number of ion. And it's really important for our calculation. Okay? Because for the chemical reaction, we will have the reaction between our ion or atom or molecules. If you know the number of our atom, molecules, or the ions, and then you can make the calculation. And the next part, we consider about copper. We want to calculate atomic weight or the mass of one atom. Okay, so we care about one atom only, the mass for one atom. And you already know in the real part, we consider about this one already, right? Because we have two isotopes in the nature for copper. We have the mass number 63 and 65. But when you calculate atomic weight, we use the isotopic mass. We don't use the mass number. Mass number A equal to the number of the proton plus with the number of the neutron. Okay, but isotopic mass is mean that we define another term in ANU. Okay, so we use this one for our calculation. And for this one, we have the fractional abundance in the nature. So we take the isotopic mass times with fractional abundance plus with the second isotopic mass times with the second fractional abundance, and then we can get the average value, and we call this one is atomic weight. Okay, or the mass of one atom only. Okay, but now we consider to calculate the mass of 1 mole of copper, and you know that 1 mole of copper we have Na equal to 6.02 times with 10 power 23 atoms. Okay, and from here you can see that 1 mole of any element we have the same number for the atom inside. Okay, and then we have the mass of one atom in ANUs. Actually, this one we can calculate similar with this one. Okay, if you have isotopic mass and fractional abundance, you can get the value like this. But in ANU, this one is mean that the mass of one atom in ANU. Okay, this is the value here. And if you try to calculate the mass of 1 mole, it means that the mass of this number of atom. If you know the mass for one atom, you can calculate the mass for 1 mole. Okay, but actually, this number you time with Na, you can get the mass of 1 mole in AMU, and you can change to the mass in gram. Okay, the mass in gram, after you change this value to the mass in gram, you can guess this value, and this value you see the same value with the mass of one atom in AMU. Okay, so you should know the difference here. The left one, we have the mass of 1 mole in gram, the right one, we have the mass of one atom in AMU, the same value. So it will be convenient for us to work, okay? But remember, different unit from here. So the mass of 1 mole of an element is equal to its atomic mass in gram, okay? So you check from our periodic table, we can see this value, okay? But if you consider about the mass for 1 mole, and we have this one will be gram, it means that the mass for 1 mole, how many gram in 1 mole, okay? And this one will be the mass for one atom only, and the unit will be AMU. That's the difference, okay? And when we talk about this one, you know the mass for 1 mole, and we call that one is the molar mass, okay? And we use the symbol M, okay? Notation M for the molar mass. Molar mass is mean that the mass of 1 mole of the substance, okay? The molar mass in gram per mole, the mass of 1 mole, okay, in gram, okay, is the numerically equal to the formula weight in AMU. Because the reverse one, we define AMU and we can calculate for the formula weight, okay? And now we change it become molar mass, okay? So you see from here, carbon 12 we define, we have the atomic weight of 12 AMU for one atom, okay? And now we consider about the mass for 1 mole or molar mass, also 12, but the unit will be gram per mole, 12 gram for 1 mole, okay? Or we consider about ethanol, C2H6O, okay? And here we have the molecular weight of 46.1 AMU, okay? So we calculate about this one in the real part already. And then we also have the same number here for the molar mass or the mass of 1 mole, right? Okay, and the unit will be gram per mole. So we separate here. We should separate here become 2 parts. Okay, so we consider about 1 molecules or 1 atom. So we have this value in AMU. But if we consider about 1 mole, the mass for 1 mole in gram, so we have gram per mole, the same number, but different unit for 1 atom, 1 molecules, or in 1 mole. Okay. So you already know about AMU and gram per mole. So now we will consider about the relationship between the atomic mass unit and the gram. So what's the relationship you have from here? So you know that 1 mole of carbon contains 6.02 times with 10 power 23 atoms of carbon. Okay, and 1 carbon atom has the mass of 12 U. Okay. And 1 mole of carbon, we have the mass of 12 gram. So you see, 1 mole, right? We have this number of atom, okay? And 1 atom, we have this value for the mass. So the mass for 1 mole will equal to 6.02 times with 10 power 23 atom times with the mass for 1 atom. And it will equal to the mass in gram for 1 mole. We have already the same value, but different unit. And then atom can be cancelled. So finally, we get this relationship. 1 gram will equal to 6.02 times with 10 power 23 U. Okay. So now if I have U, I can change become gram. Or I know gram, I can change become U. Okay. And the next part, we consider about the mole number. The mole number we already defined before, right? So we know that's the N, okay? And when we work with our substance, we may have the mass, right? So the mass will be in gram, okay? And the molar mass, you know already, the mass for 1 mole, gram per mole. So how to calculate for the mole number? Mole number equal to the mass of the substance, divide for the molar mass of the substance. Mass of substance is mean that the problem they may give you or in some experiment you want to weight maybe 1 gram, maybe 3 gram or 10 gram or maybe 5 kilograms something. Okay, this is the mass we calculate in gram. Okay, and with that mass we divide for the molar mass of the substance because 1 gram of copper will be different with 1 gram of Al. Because we have the difference for the molar mass we mentioned already, right? So we cannot use 1 gram or 3 gram for calculation. directly, okay? Because we see that the different number of atoms in 1 gram of carbon or maybe 1 gram of any substance, okay? So we should change become the mole number. So from here, you can see that mole number equal to the mass divided for the molar mass. Mass is mean that the 1 in gram. Molar mass, that is the properties of the substance. How much, how many gram for 1 mole, okay? Because you have gram, divide for gram per mole. So gram and gram can be cancelled. So the unit here will become mole. We can make the balance for our unit as well. So you can get this value, okay? So for the problem, if you calculate for the mole number, you may confuse. Maybe some problem they give you gram, or some problem they give you milligram, or maybe they give you kilogram, okay? But the unit when you check from periodic table always gram per mole. So you will confuse. So how about the unit for our mole number? So for this kind of problem, you just carry the unit with your calculation and you can check your calculation. So you have the mole maybe equal to 1 gram divided for maybe 64 gram per mole. And you know the unit here will be mole. So the correct one. But if you have 1 milligram and you divide for 64 gram per mole, and you can see we cannot cancel this term, okay? So you can get this one will be millimole, or you need to change milligram become gram for your calculation as well, okay? So we have the mole concept already, and you know what is the meaning of mole and why we need to use the mole for our calculation, okay? And also relationship between the gram and U in our uh, the uh, the calculation when we consider about the mass for one atom molecules or maybe the mass for 1 mole, okay? So that's all for this part, okay?